Welcome back, everyone. In today's lesson, we are diving into one of the most important concepts in modern software development. It is called dependency injection. Now, I know that sounds simple, but at the end of this video, you see it actually quite simple. We are going to build a payment processing system that is flexible, testable, and follows enterprise level design pattern. Let me show you the folder structure first because organization matters. So, take a look at our project structure inside the VS Code. We have the program.cs, our entry points, and we have the interface folder, which is this. This folder, this holds our contracts. Then we have the service. We have the service folder. This holds our implementation. Now, this separation is crucial. We are separating what something does from how it does it. This is the foundation of dependency injection. Let's start building this step by step. So I'm going to open my iPayment processor in our interface folder. So we have the structure already here. So basically, I will create an unimplemented method, which is processor. So payment, then decimal as one of the arguments. So that is it. We are done with the iPayment processor. Now let me explain what happened here. Now, an interface is like a contract. It says if you want to be a payment processor, you must have a method called process payment that takes a decimal amount. Notice there is no implementation here, no curly braces with code inside, just the method signature. Now this is abstraction. We are defining what needs to be done, not how to do it. The how will be handled by the classes that implement this interface. The separation of concerns is what makes our code flexible and maintainable. Now we are going to move to the next one. Under our service, we're going to move to credit card processing or credit card processor. So here now, I will say public void, then process payment. So we already have it. So here we are going to implement it. Decimal, then amount. So we'll say console.writeLine. Console.writeLine. Then let's bring our string interpolation. Processing credit card payment off. So we're going to say, okay, so since we are doing string interpolation, we don't need, we can just do this and then put the amounts. Then put the currency sign. This is the currency sign. So this will generate the currency sign. So I'm going to explain this code now. Let me break this down like you will understand. Now we have public class credit card processor. And we didn't complete it, so we have to implement this class iPayment processor. iPayment processor. So okay. So we have public class credit card processor. Then implement iPayment processor. Now the column followed by iPayment processor means this class is signing the contract. It says or it's saying I agree to follow the rules defined in that interface. Now because it signed this contract, it must implement the process payment method. Now if we try to remove this method, the compiler will give us error. If we try to remove this method, the compiler will give us error. So you can see, so we cannot remove the method. Now inside the method, we have our concrete implementation. The actual how, here we are just printing the console, but in a application, this would connect to a bank API, validate the card, charge the customer, and do and so on and so forth. Now, this is the implementation detail that the interface abstracted away. Let's move to the payments or the paper processor. Paper processor. Now, I have a class paper processor. Then I will implement the interface payment processor. Then I will bring in the unimplemented method, which is the abstract method for it. Payment process payment. So I will say decimal, then amount. So then I'll say console.write line. Console.write line. Then processing paper payment. Then we will call the amount. And don't forget the currency sign. Yes. So what is happening here? Now notice same interface, different implementation. This is flexibility in action. Our system can now handle multiple payment types, adding a new one like Apple Payments or Apple Pay or Bitcoin Pay. Is as simple as creating a new class that implements iPayment processor. Now we don't have to modify existing code. We just extend this follow the open close principle open for extension, close for what modification. So let's move to another one, which is an index service. So index service. I'm calling it index service, but it is called order service. Now, in our order service, we are going to have a private field. So we are going to make it read only. Then iPayment processor. Then we say so the reference variable will be payment processor. So we have public. Let's bring in then order service, then iPayment processor. Then you can say payment processor. Yeah. So payment processor. So what is happening here? I can say underscore. This equals to payment processor. So just follow me, I will explain. So public void place order, then decimal, then console dot write line. Let's just say placing order, then just say this like it's placing order. So say underscore payment processor dot process payments, then we can now call the amount parameter, then console dot write line, then we have order completed. So what is happening here? Now let me explain this slowly because this is crucial. Now this line of where is it? Line 8. This is line 8. Now line 8. we are declaring a private field that hold a reference to any payment processor. Now notice the type is the interface, which is iPayment processor, not a concrete class. We depend on the abstraction, not the implementation. Now, um, now um, line 9 to line 13. Line 9 to line 13. This is a constructor. It takes an iPayment processor. It takes an iPayment processor as a parameter. Now, this is called constructor injection. The dependency is being injected from the outside. Don't forget, from the outside. Now, see line 11. Line 11. Okay, we assign the incoming parameter to our private field here. Now the whole class can use this payment processor. I hope you are getting it. Now the next line, the next line, which is the place order, line 14. The place order method uses the injected processor. It doesn't know and doesn't care whether it's credit card, paper, or something else. It just calls process payment. Now, here is the key insight. This class does not create what it depends on. It receives it. If this class has written underscore payment processor is equal to new credit card processor, like the way we used to write, it would be tightly coupled to credit card. To change payment method, we would have to modify this class again. But now this class is completely decoupled. It works with any payment processor that implements the interface. This is dependency injection, and it makes this class testable, flexible, and maintainable. Don't forget, this is a very nice senior concept. Now the last one, we are going into our program.cs. Now let's see this work in practice with our program.cs. In our main class, I'm going to write this console.writeLine. I'm sure by now you must have mastered this. Then select payment method. So select payment method, then another console.writeLine. Then I will say 1. So I'll say credit card. Then next one. Then next one, I'll say 2 for paper. Don't forget. So I'll say string choice. Then I'll say console.read in order to console.read line in order to read the information from the console. Console.read line. Then the next line, I'll bring in the iPayment processor. Then payment processor. Then I will say if conditional statement, if choice is the same thing as 1. Same thing as 1. So I can say payment processor equals to new credit card processor. Yes. Payment processor equals to new paper. Then can say order service, then order service, new service, new order service. So pass the payment here, and pass payment processor here. Hope you are following it. So we have order service. Let's just say 500. So that's it. Order service dot place order, then 500. We are using this M because it's a decimal. It's in decimal. So let's walk through this. Let me explain this so you will understand what is going on here. You understand what is going on. Now, first, we prompt the user to select a payment method and read their input. Now, payment processor, or let's say iPayment processor, then payment processor, then payment processor. We declare a variable of the interface type. This variable can hold any object that implements the iPayment processor. Now, based on user input, we create the appropriate concrete implementation. If they choose 1, we create a credit card processor. That's when they choose 1. Otherwise, we create a paper processor. Now, order service, this line is equal to new order service. Then order service is equal to new order service, then payment processor. Now, this is dependency injection in action. We are passing the payment processor into the order service constructor. Now, the order service doesn't know which one it got, and it doesn't need to know. Now, we call the order. It uses whatever processor we injected into it. This is what we call manual dependency injection. We are doing it ourselves. Now, in ASP.NET Core, there is a built-in container that does this automatically. But understanding the manual approach helps you appropriate or help you appreciate what the framework does for you. Now let me explain why this matters in the real world. Imagine a typical enterprise application without dependency injection. There's going to be chaos. Without dependency injection, there's going to be a lot of chaos. So I'm just moving to the code. I read it. Okay, so now this class is not permanently tied to credit cards. If you want to, let's say we have something like credit, we have something like private. I will do something like this. Let me do something like this. Let's just say, I just want to give an example just to explain this. Sorry. Let's just say private credit card. Sorry, I will soon run our program. Credit card, then underscore processor equals to new credit card processor. Now see this line. Basically this class, or rather let us say this class is permanently tied to credit card. If you want to add paper, modify the class, add Apple Pay, modify the class, write unit tests, you are actually charging real credit cards. Every change risk breaking existing functionality. The class is rigid, understandable, and tightly coupled. With dependency injection, the class need to add a new payment method, create a new class, inject it, no changes to existing code, need to write unit tests, inject a mock processor that doesn't actually charge anyone. need to change behavior at one time, just inject a different implementation. Now, this is why dependency injection is considered an enterprise level pattern. It's not about writing more code. It's not about writing more code. I have said it before. It's not all about writing more code. Sorry, I need to put that code here. Sorry. Let me cut it. Cut it. Come to our credits session. So let's just say something like that. So I will delete it, don't worry. So so basically just inject a different implementation. You need to change behavior at one time. This is why dependency injection is considered an enterprise level pattern. It's not about writing more code. It's about writing code that can grow and change without falling apart. I hope you get it. Now, in conclusion, let's recap what we learned today. We have learned interfaces define contract. We have learned that interfaces define contracts. The what without the how. Concrete classes implement this contract with actual behavior. Dependency injection means classes receive their dependencies rather than creating them. This creates loosely coupled code that's flexible and testable. All right, so I'm going to run the program for you to see the outputs. To run the program, I will do this up here. Then I'll go to this terminal. I need to go to my git batch. First of all, confirm if you are in the root folder. Then this. So yes, so I need to change to that folder. So then once I have changed, all I need to do is to say .net run. So I'll say .net run. Yeah. So it's according to the program, it's going to request for either 1 or 2. 1 is for credit card, then 2 is for paper. So let's enter 1. So if we enter 1, you will see Stack Overflow repeated. Stack Overflow repeated. So sorry, there's an error here. Oh, sorry. We didn't remove this. We need to remove this. So let's save this. Then we are going to rerun it. So to run it, we just let's rerun. So I'm going to do this. So to run the program, we go to this. We are going to run the program now. We come here and then go to terminal, then go to this. Make sure you change to git batch. It depends which one you prefer. Then let me list before you run. Try to list if you are in the root folder. So I'm going to change to the root folder now. Change then. So I'll say .net run. .net run. Yeah. So it's prompting me to choose either 1 or 2. So if I choose 1 and 1, you see placing order, processing credit card payments of 500 naira. Order completed successfully. So if you put 2, to still run the same thing as well. Now, if this helped you understand dependency injection, please like and subscribe. Drop a comment if you have question. I need every single one. Thank you for watching and thank you for staying tuned. Take care and bye for now.